Hello, Integrated 2 students. This is Miss Schick. We are going to look at some composite figures today, or finding the area of some composite figures. A joke is, what do you call an alligator in a vest? What do you call an alligator in a vest? All right, a composite figure basically just means that you're going to be finding the area of more than one piece. You may have to chop something up into shapes you recognize. And then it looks as though we're probably going to be adding them together. So let's see, to find the area of a composite figure, divide it up into spaces or regions, like I said, of your normal everyday shapes. It has basic shapes. Find the area of each one, and then we're going to add them together. All right, let's do this. You might want a couple like fun pens, highlighters, colored pencils, just because I'm going to be using them, and you're probably going to want yours to look pretty too. So like I said, shading, marking, labeling, dividing them up into colorful shapes might be your favorite thing today. All right, so I see a rectangle. We can call that shape A. We can, if you're just working with pens or pencil, you know what I mean, you can just kind of shade it. I don't know, just shade it so that it's a little bit darker than maybe this other piece of our shape. The second shape that I see is down below, and I'm going to call that a trapezoid and or shape B. So at this point, you would want to go to your formula sheet and or section 9.1 and write down those two formulas. So for a rectangle, it's base times height. For a trapezoid, base 1 plus base 2 divided by 2 times the height. Remember, one of those bases is too short, one is too long, and maybe we want to do this instead. Let's call that B. So the area of shape B is base times height. The area of shape B is finding that base, the two bases, averaging them, and then taking it times the height. Okay, so what do we know? What do we not know? I can tell you that this is 12. I'm just going to slide it over. Sometimes when we give you certain lengths, it's helpful, and then maybe it's a little bit more helpful on the other side. Another rule there is that 23 would be an opposite side with the top. I am able now to find the area of shape A. Could I have just done the 23 and the 12 that I saw in the picture? Of course. Is 23 an example of a base, and is 12 the height? Yes. We're going to multiply those together in just a moment. Now we need to figure out what's going on with the trapezoid. I have the base of 23. I have a base of 15. Those are awesome. I just maybe don't know what the height is. So an important piece of detail that is missing is, what is the height of the trapezoid? Sometimes we like that to be sort of in the shape so you can prove that it's perpendicular. So standing up straight, you know, a straight up and down length. I need to kind of fill in. Let's see, what do I know? What do I not know? Oh, I see. So the side of the rectangle is 12. The entire distance from top to bottom of our composite figure is 18. That means our height, I believe, will be 6, the difference between those two. Base 23, base 15, divide by 2, all of that times the height that we just discovered. And now all of that just kind of goes in the calculator. 23 times 12. Is 276. So the area of A, 276. We are going to be adding the area of B. So 23 plus 15 is 38 divided by 2, 19. So 19 is absolutely a number between 23 and 15. And we're going to take it times the height of 6. Got 114. Therefore, our total and complete posit area is the sum of all of them. I got 390 centimeters squared. So you're going to want to, like I said, chop your shape up into shapes you recognize. I would suggest doing it that way rather than surrounding it and creating spaces where you would subtract pieces. In other words, if you were thinking about turning that kind of into a full-blown brick, I don't know if we have enough information to chop it up into smaller pieces. The way that we've divided it up, I think, is the only way to do that one with the information given to us. All right, that second one sure looks like an ice cream cone. And so we are going to find the area of I'm going to call it shape A. So some strawberry ice cream there. And then shape B, which is down here looking like a cone. I can call, like I said, shape A, shape B, looking at maybe that formula sheet and figuring out how do I determine the area of these two. That top one is definitely a circle, and to find the area of a circle is pi r squared, but that is a semicircle or a half circle, or sometimes called a hemisphere. As long as you know that it's half of a circle, we're good. So we're going to determine the area of that circle and then divide it by 2. The triangle on the bottom, we're going to call that shape B, is 1/2 base times height. All right, so for shape A, I need the radius. Don't have it. In the picture, you can see the diameter is 16 from one end of the circle to the other. Therefore, your radius will be 8, and maybe you want to label it that way on your shape. So each radius on either side, 8 and 8. We need the 8 in our formula. And there we go. We'll use a calculator in a minute, but I have found all details that are needed to find that. For the orange shape, the triangle, it is what you might interpret as upside down. You could always redraw it. The base, I'm going to say, is 16. So how long is this triangle? The problem with what we have is how tall is this triangle is not in the picture. You have to have perpendicular proof, a right angle symbol. You have to see that mark that shows you how long by how tall. So I will be drawing that in. That right there, I did my best to draw it as perpendicular as possible. That is how tall that triangle is. Because 16 was how long it is, you have to know perfectly how long by how tall. I'm going to put, I'm going to call that H. Because in the formula, I've described that as the height of the triangle, and I have the base as 16. I am going to redraw a little bit of this triangle right here. I'm going to separate it because I want you to be able to see it by itself and have a plan of attack on how to discover what the height is, or what H is. This is 8 and this is 17. That is a right triangle on purpose. We have lots of right triangle rules. This one, because we have 2 sides and no angles, we will use Pythagorean. You can always play that fun game, which is to guess, like what do we think this is? What do we think that height is? Well, from my picture and from what I see of 17, I think it's probably, I don't know, 14, 12, something like that, because it feels like it is less, it has to be less than 17, but it feels like it might be a little bit more than 8. Let's check things out. The 2 legs are H and 8. You decide how you want to plug those in. It's up to you. We get 64. 17 squared, I think, is 289. I guess I better check that. I'm not 100% sure. Yes, 289. Then we're going to subtract 64 and end up at 225, which is way too big. Remember, I told you, I thought H was a little less than 17, not 225. To continue solving, you will take the square root of both sides and find that that height is 15. Really close to 17, just like I said. Now we have enough information to find the area of the triangle. We know how long by how tall. I think I have all details. I think I have everything I need to know. So the area of A is 64. 8 times 8 is 64. So 64 pi divided by 2, 32 pi. That is the exact area of the pink semicircle, or the top that described kind of as the ice cream. Now the base, the triangular piece, 16, half of 16 is 8. 8 times 15 is 120. So the exact answer for this is 120 plus 32 pi. Again, 120 plus 32 pi. The decimal for all of that is about 220, I put 0.53 meters squared. It's up to you how you want to represent your answer. If you want it to be exact, then you have 120 plus 32 pi. You could not combine those like terms. They are not like terms, just as if they were 120 and 32x. The same rules apply, is that you can't combine them. But you can, if you have them in decimal form, combine them into 220.53. Okay, so far we've had two different shapes. Hypotenuse, sort of, I mean, somebody might say on that second one there were three shapes. The half circle and then two triangles. You could have done it that way. Or the whole triangle together. It's up to you. All right, what do we have here? We have the potential for three shapes, maybe four, depending on what you see. I see a square, we'll call A. I see a triangle. I'm going to go with the big one if you don't mind and call that B. And we have a third shape down here, which is, call it C. So three different shapes. You can shade them, outline them, redraw them if you want. I've seen students before like completely take it apart and look at each one very much separately. It's a great idea. All right, A, that is a square, so we're going to take either base times height or side squared. The triangle, which, oops, I keep doing that. Let's call it B, would be 1/2 base times height. And then C, I think that's a trapezoid. Base 1 plus base 2 divided by 2 times the height. Okay, so my plan is laid. Now I need information. To find the area of that square, I need to know the sides. Eek, I don't think I have the sides. I see 25.4 over there. That's all I see. Okay, so it is time to figure out what's going on with this square. I am going to focus my attention for a minute on this triangle, this yellow one, because I feel like I have some information. Not enough, but some. So that yellow triangle, where should I put this? I think I'm going to put it down here. This is 9.6 and this is 12. And now you're going to say, but wait a minute. I thought the outside was 12. I know this picture is kind of deceiving. So the 12 is where the tick marks are. So that's 12. And then the 9.6 is trying to point at that height. So the picture is a little bit of a mess. Sorry about that. We are going to find this length using Pythagorean. X squared plus 9.6 squared equals 12 squared. 12 squared is 144 minus 9.6 squared. I got x squared equals 51.84. Taking the square root of that, I got 7.2. All right, believe it or not, that 7.2 is the key to just about everything in this picture. 7.2 is this, 7.2 is that. Therefore, we have now determined that the side of the square is 14.4. That took some work. So our area of our square will be 14.4 times 14.4. Ooh, okay, we now have a triangle. We're going to do the whole triangle at the same time. 1/2. The base is 14.4. The height is 9.6. And then our trapezoid. Do we have enough information? This is 14.4. Oh goodness, do we have the height? Oh, we don't. We do not have the height of this trapezoid, but it will be the difference between 25.4 and 14.4. Oh, I got 11. So the height is actually going to be 11 meters. Again, it's chopping this up right here with 14.4 and with 11, and that's how you get back to your 25.4. Basis, 14.4 plus 10 divided by 2, all that times 11. Okay, so the red part was our plan for the formulas. The blue is after I found all those pieces. Now we're talking. Now we can actually find some areas. Okay, so I'm going to switch to green here. So this one right here is 207.36. Hopefully you're doing this with me and checking my work. This one, B, is 69.12. Probably should be checking my work along the way here. And then my last shape, 14.4 plus 10 divided by 2 times 11. 134.2. We now will be adding all of those three things together, all of the green totals. 69.12 plus 207.36. Final answer is 410.68. Composite figures basically are just a bunch of shapes touching. You're separating, you're finding each one separately, and then at the end of the day, adding all of those up to make one final area. Okay, last one. There's only 4 today. Sorry, only 4. So we're going to start shading. So if you've got your fun markers or highlighters, here is shape A. That is a triangle. We can say this one over here could be shape B. Let's do it. And then finally, our last and final shape is a, semicircle or half of a circle. All right, so now as we make a plan for the formulas, I'm going to start in, I guess we've been starting in red. So the formula for A, 1/2 base times height. Shape B, base times height. Shape C, a semicircle, pi r squared divided by 2. All right, now the hope is that all of those pieces of information are on the shape, and they are not. Okay, so I need a radius. Okay, I can fill in some information here. I'm seeing some details, like this is 9. And you might say, where did that come from? Well, the rectangle in orange has opposite sides congruent. So that will be, the radius is 9, and this length is 9, because it's just another radius. I am now able to find the area of the pink shape C. Can I find, actually I cannot. And this is 9. We're going to need this one. Okay, so just a minute. It's going to take me a minute. This is 9. If we take that away from the 26, I think that's 17. So we've got 17 from here to here. That's the height of the rectangle. And how I got that was I took the radius from the circular piece, or the semicircle, I slid that over and let it play a part with the 26. How much of the 26? 9 of it. What was left? 17 of it. So now I have 17, I got 7 on the top. That means this is 10. Okay, now we got to talk about what just happened there. So from here to here is a portion of the 17. As you slide that 17 over, but then see that little top, that top part is 7? That means the height of that triangle is 10. Wow, that was a lot. Okay, area of the triangle. What is the base? 9. What is the height? 10. I'm ready to roll with that one. Height and base of our rectangle. I have a 17 and I have a 9. Ready to roll with that one. The shape with the circle, a half a circle, the radius is 9, and remember it's half. So remember, the red is the formulas based on what shape it is. The blue was determined after I found all my details. The length, the width, the base, the height, the radius, all the things. What's left now is to do the math. 90 and half of that is 45. 17 times 9, let's try it. 17 times 9, 153. And then 81 pi divided by 2. It just went all of a sudden to a decimal because of the fact that it was going to be, excuse me, a decimal anyway, right? With the dividing 81 by 2. I did take it times pi. Our final answer is the sum of all of those 3 shapes. Adding 153, adding 45. I got a final of 300, maybe just a second, 325.23. It was feet, and those feet are squared. All right, composite figures. taking an entire figure and chopping it up or dividing it up into shapes that you have found the area of before. Sorry about that. My suggestion is just take it slow, shade them in, redraw them, however it would be helpful for you, because looking at them on the very surface is a little overwhelming. And you don't have a formula for the one shape. There's not a formula for whatever that is over there. A, B, C, there's not a formula for that. You have to chop it up into shapes that you know. All right, today's joke was, what do you call an alligator in a vest? It's one of my favorites. An investigator. Kind of have to say that a couple of times, don't you? An investigator. What do you call an alligator in a vest? Have a wonderful day.